Hey, Christy.
Are you feel like we're doing better with API?
I mean, I did the homework, so it's I'm waiting for the programming part because I know we're gonna have to do it programmatically using JavaScript. So when I did it before, like on a Udemy course. So I had to like go do like a weather app where you can go. They put in a location, actually go get the weather from an API somewhere.
Oh, you did it on your weather app that we just did?
No, but before I bought a course on Udemy, and one of the projects in the course is to build a weather app using an API and JavaScript and Node stuff.
I'm still, so I'm at the very end of the JavaScript pre-code camp because I know I just breezed through it. And if I didn't understand it, I kind of sat with it until I could piece together and understand it. So I still didn't do the array. I'm like, I think I understand loops now. I think I understand for, loops, and while. But it's just slow. You know what I mean? It's not instant. It's like my brain is like, okay, I got this, but it's just not, my engine ain't moving as fast as probably.
It's a process. It's a process.
Right, so I watched a video today. I posted it in the chat where the guy was talking about how it's not about memorization. And so it's hard to transition your brain from memorization because you see all this stuff and you feel like you need to memorize it so you know how to do it. But he explained that you have to understand what it does, and then you can go find, you can go like Bootstrap, CSS, different places. You can go find what you need, like on W3 schools, to do what you need to do, but you got to understand. It wasn't concepts. I forgot the word he used, but it's coming. It's just coming slow.
I watched the video. It was a good video. Then there was another one that played after it. So it was two interesting videos back to back. Yeah. So like my experience with like program was primarily with school. And then on a basic level, I teach the kids, some stuff, but that's block-based programming mostly. So like Scratch, a little bit of text-based stuff. And knowing the basic concepts, like you said, loops, making decisions, how to work with different structures like arrays and things like that nature. So that helps me understand a little faster, but there's still a lot of stuff I don't know. So like you said, and the guy said in the video, understanding, okay, I need this to happen, and then where to find that information on how to do it or how to think about the steps to make it happen.
Right.
Because like even with stuff, when we go and Max is teaching us certain stuff, sometimes we get caught up in wanting to have our code exactly where his code was, or, type it exactly the way. That's not necessarily the way that it works. He's showing you a way to do something. And, for the sake of time, you following his way while we're in class, that's good. But there's multiple ways to do the same thing a lot of times. So,
when you don't know nothing, you're not brave enough. You're not there yet. Like, you gotta get a level. It's like a level of confidence. Like, I created a separate website. I bought 2 websites. I went on and made my own website, put my own stuff on there. But I used a lot of what we use to make our portfolio page. So it's just my own separate web page. And some of the stuff wasn't working on it. And so I had to like really keep playing with it. So that built my confidence to where now, okay, yes, you can, this is what you can do. You can do this. Now I gotta get to the, you know what I mean? It's like a building, like it's a block. And then you put another block. It's like, but you gotta have a solid foundation. So it's another block and it's another block. So I mean, it's just that it seems like you know, when we was working, it seemed like it was dragging. Like, you know, it was drag, like the weeks, the days, the weeks, the months. But now don't it seem like time is like light speed? I'm like,
yeah, like time was flying when we was working for me, like when I was helping train people and things of that nature. Like it was flying and like the calls was crazy. But like towards the end, it was just like, yo, I'm ready to like, yeah.
a time when we didn't have no calls and
yeah, it was dragging.
it was like, oh my God, is this ever gonna end? Just shoot me. So but what I'm saying is now it just seems like time is flying. And I'm like, we only had so many weeks. And
yeah.
and time is moving faster than my brain. That's just how I feel. Like time is moving faster than my brain. I'm doing the best I can. Like I'm just like every day. I work on something every day. I make it a habit. I've done something every day, and I'm like, I feel like I'm getting it. I don't feel like I'm lost, but I'm just like, it just seems like I need time to slow down a little bit. I need my brain to speed up a little bit. And then it's like summertime, and then it's like I'm supposed to be working out. Like some days I don't go to the gym. I'll be like, okay, I can't go to the gym because I don't want to use up all my good energy. So I stay home and skip the gym and work.
Listen, you have the gym in your headset. Believe me, listen.
I know. I listen, that's a whole nother set of stuff. I still have, I'm telling you, it's too many things going on. Like if I had already had that set up where I could just go to it, but I'm still exploring and still learning. And I don't really got no space in my brain for nothing else. I ain't even watched my shows. I haven't even watched my shows. Like I missed a lot of my shows. And you know what I'm saying? Like it's just like, I'm so consumed. I'm getting better. Once I finish my we doing the capstone for my yoga class. Once I do that, I think I'll listen. Today I threw caution to the wind because I started watching that Michael Todd video, the one Scotty had told us about.
Yeah.
Man, that thing was so good.
Yeah, I went out and took a peek from the book and went and rode 5 miles real quick before class on my bike.
On your bike?
Yeah.
And see, that's the other thing. When I ride my bike, I usually ride like 10 miles, stuff like that. So 5 miles to me seems like I really didn't do nothing, but I got to get out that habit. Now I did walk twice today. I walked from my house. I walked 3 miles, came back. And then I walked 3 miles, but I was listening to the video while I was walking. So I like killed 2 birds with 1 stone.
Okay.
But where's everybody? We early, they late.
I think they're late.
Hi.
Hello.
Hello.
Mel said totally agree, Christy. Well, totally agree with what? I said a lot.
About the video part.
No, yeah, that was in the beginning of your speech. When you're speaking to how you don't have to know everything in code, you just have to kind of understand what the concepts are and what they can do.
Oh, I thought I was using the wrong word. I didn't think the word was concept. So I was trying to think of because it was a video and I shared it in the private chat, and the guy was saying that, you know, in the interviews, he's like, don't try to memorize stuff, because if you go to the interview, somebody might change the way they ask the question. So now you're going to be off. So I just feel like my brain be like, I feel like, you know what, every time I think about a whiteboard, I think about Sheldon on Big Bang Theory. And I'm like, if I literally have a whiteboard in my living room, I'm going to be a complete and total nerd.
Well, I agree with you, Christy, about it going by really fast. It feels right now like if we had 2 weeks, 2 weeks to do each of these weeks, the pacing would be perfect.
Right.
It's like I can't even keep up with all the videos to watch, all this article and that article, and then the classwork and homework.
Right.
Yeah, it is a lot. Very fast.
For sure. I don't have a good feel on how this cohort's compared to previous cohorts, but it seems like you're really packing in for example, my section here last time was 2 weeks. This time it's 1 week. So
maybe you should come back for another week.
I
Can we
mean,
take a vote? Should we put that in that feedback form? I'm gonna put that in that feedback form. How you spell your name again?
I will say in the past, I have come back for a day or two later on. There's a few lessons that I've formulated from previous cohorts that generally students have liked. So sometimes I try to ask to see if they have some time to fit me in again, and sometimes it happens, sometimes it doesn't.
I can
But-
say that the pace has been very good this week. Like I don't feel overwhelmed, like you're moving too fast and I'm not grasping what you're saying. So that's a plus.
Okay, nice. Well, I still not seeing quite as many people as I would like to, but I think we're about ready to get started here. What do you think, Mel?
Yeah, we can get started, Ryan. We're good.
Cool.
Yep.
Okay, because we have a decent amount to get through today. Okay, let me share my screen. So I'm back to the same presentation. Today we're going to be talking about a bunch of different headers. You can include in HTTP requests and they can come back in responses, sort of standard header keys and values. And we're also going to be talking about this thing called JSON, which I think you've had a little bit of exposure to. We're going to really take a deep dive into it because it's going to become important that you have a deep understanding of it going forward. Before we do that, though, let's just do a quick high-level overview of what we talked about so far. So the first day, we talked about HTTP. HTTP is the protocol that web browsers speak. It's how web browsers talk to web servers. I sort of talked about all the different pieces of a web request, an HTTP request. Things like method, path, request headers, things like response headers, status codes. The second day, yesterday, we talked about fetch and curl. Well, actually, I guess the first day we also talked about Postman, but talked about fetch and curl. Curl being a way you can make HTTP requests in a terminal. Fetch being a way you can make HTTP requests in a web browser. And it looked like by the end of the day, most of you had your head wrapped around making requests with fetch, which is good to see. So today, we're not going to be covering any more libraries. We're kind of done with that. Postman, fetch, and curl, those are sort of your three libraries we're going to be talking about. So we're done with that. We're just going to be elaborating on more things you can do with HTTP itself. So all the stuff we're going to be talking about today sort of applies no matter how you're making a request. Postman, curl, fetch, whatever it may be. So we're going to start off with some headers. And the headers we're going to talk about today, we're going to talk about a few of them. The first two are called content type and accept. And we're going to talk about authorization, location, cookie and set cookie, and some custom headers that start with X. In the past, I've talked about a few others, but I've left them out just due to time because we got a lot to get through today. There's a lot more headers. The reason why we're talking about these ones in particular is because I think they're kind of important to know. And these are all headers that are built into the HTTP specification. Headers that if you include in a request or get back in a response, they have standard meanings that sort of are implied and that you can sort of like assume the data coming back is what it is based on those header names. Okay, so the first one we're going to talk about is content type. So content type is a request header, and it describes the format of the data that's contained within the request body. So remember, requests can have a body. They can have whatever sort of content you'd like to put in that body. And that content can be in a bunch of different formats. Like so far, all of our response bodies have just been text. Like we've just put like raw text in there. But they could be really anything. You could put any sort of binary data in that request body. You could put a PDF, you could put an image, you could put a zip file. You could even get fancy and do something like, I don't know, put some HTML in there. So the way that content type works is you specify this header and you set it equal to this special thing called a MIME type. And this MIME type, you can think of it sort of like a file extension. It serves a similar purpose, sort of identifies the type of data that's being sent in the request body. MIME types are sort of structured with this format where you have sort of a more generic category, then a slash, and then a more precise category. And usually there's just two sides to it. So for plain text, the MIME type is text/plain. So generally, so far, everything we've been doing has had a content type of text plain. But PDFs, like if you wanted to include a PDF in a request, that'd be application PDF. A PNG image would be image PNG. HTML is text/HTML. With time, you'll memorize a lot of the common ones. I'll also mention, because we're going to talk about JSON later, the MIME type for JSON is application/JSON. The default value, though, so if you don't specify a content type, usually things will assume the default content type is this thing called application octet stream. Octet stream, so bytes, 8 bits, octet, stream of bytes. That's really what that sort of means. So just a stream of sort of ones and zeros that is sort of unspecified in what they mean. Yeah. So that's what content type is. We're going to use this in a second, but I want to get through a few of these headers so we can sort of do some demos with multiple of them and really do some fun things. Okay, before I move on, any quick questions about content type? Okay. Oh, yeah, let's talk about MIME types in particular. So MIME type stands for multi-purpose internet mail extension, kind of a weird like thing. But the reason why it's called this is because they originally were used for email. They're part of the email specification, and were sort of co-opted for web for HTTP. Yeah, sort of similar to a file extension, kind of already said that. There's a really good list on Wikipedia of a lot of MIME types. If you're sort of like really kind of into this and want to read more about it, you can click on this link and take a look around. Yeah. Okay. So you might have guessed there's a header for the data that you're sending in the content type of that header you're sending in the request body. But there's probably got to be a header for the response body too, and you'd be right, and that's accept. So what's important is both content type and accept are request headers. You specify them in your request. That being said, content type is the MIME type of the request body. Accept is the content type of the response body. So when you use an accept header, you're telling the server, when you send me back data, I would like it to be in this format. So why is this kind of helpful? Well, let's say you have a server that can sort of send back data in multiple formats. Like for, here's an example, let's say, maybe you've got data that you could send back in raw text form, or you could send back in sort of like a nicely formatted like HTML form. And maybe the plain text one is good most of the time, but sometimes you might want the fancier HTML version because you're rendering it in a place where like formatting is allowed. So what you could do is you could write the server in a way where it could handle this sort of accept header properly. And when you make the request, you can specify an accept header saying, I would like the accept header, I would like my response body to be text plain. So in other words, I want plain text back. And then when you get back in the response, should be plain text. But then you can maybe specify text HTML, and then you should get HTML back. You can think of this though more like a recommendation. It's not like 100%. You're just telling the server what you would like to get back. Yeah, it's definitely not always going to happen, but if the server is doing its job and you're sending a not completely weird content type, it should be fine. Some servers actually, if you send it a content type in accept that it just doesn't know how to return back, it'll actually give you back a 400, and it'll say like, I can't give you data in that format. What are you talking about? 400 starts with a 4, so it means an error that sort of was sent in the request, a client error. So yeah, that's accept. So you can see here, here's an example of content type and accept in curl, or in, excuse me, Postman. You can see that the response there, I'm getting back HTML, which is sort of what I expected and when I made that request. My accept was text HTML. Okay. I promise we're going to do some demos on this in a second. But I want to show you, I want to get through a couple more of these headers before we do that. Okay. Authorization. This is a pretty important one. So on the web, it's sort of important that some things aren't publicly accessible to everybody. Here's an example maybe of a case. Like, let's say you want to visit something like a web dashboard for a system, or like a tool, or maybe like you want to view like your Gmail inbox. Those are things where you don't want anyone to be able to access them. You need some sort of like login workflow. You need to have some sort of way where you can authorize yourself. So there's generally two terms for this in web. This concept of authentication and the concept of authorization. I will say that they sort of get mixed together, and in this case, we're sort of end up doing both with this. But authentication usually refers to the work done to verify that you are who you say you are. So in the case of maybe authorization, logging in might be an example of authentication. Excuse me, that was probably way too confusing because I just mixed those up. Logging in is an example of authentication. An example of authorization is used to sort of verify you have the permissions you need to have. So you might be who you say you are, but if you can't access the thing, you still shouldn't be able to access it. So in order to view a thing on the web, usually you have to both authenticate and authorize. So you have to do both. And this header here is one common way when you're making a web request that you can specify information of the web server to sort of tell it who you are and the permissions that you have. So the way the authorization header works, so the name of the header is authorization. It's sort of confusing because this header is authorization, but it kind of handles both authentication and authorization. It was sort of a bit of a misnomer named header, or misnomer, I guess is numerical. Misnamed, I don't know. There's a word there I'm missing. But it's sort of a confusingly named header. Anyway, though, the key is authorization. The value is two things. They're space separated. What's called the scheme and then the value. So there's a couple of different standard schemes. The ones that you're probably most likely to run into are basic and bearer. Okay. So what basic allows you to do is to specify a username and password. So imagine this. Imagine you have some sort of web resource and you want to implement very straightforward authentication. What you could do is you could have someone require that when someone makes a request to view that thing, they include an authorization header. Then they require you that they use basic auth. The way basic auth works, I'm going to get into this a little bit here just to show you an example. In practice, I don't think you're going to use basic auth all that much, but I think it's going to sort of help cement what exactly it is. The way basic auth works is you do something like have a username. I'm going to say my username is Ryan, and then you have a password. Let's say my password is my password. And what you do is you take the username, you put a colon after the username, and then you put the password. You take that string then, and then, wait, need B2A. Yeah, and you base64 encode it. So here's an example from the question from yesterday where base64 comes into HTTP. You base64 encode it, and then when you make your request to the server, you include authorization, basic, and then this thing. Now, why do you do that? Why is that important? Well, it turns out your username and password, it's possible for them to contain weird characters, and or to be binary, or to be other sort of weirdly unprintable or hard to format. So this sort of process by base64 encoding it tries to make it so that it's always printable and always formattable and easy to send to the server. It's sort of an implementation detail though. But you can see here how the server, once it gets this, it could take this base64 thing here. It could see you got an authorization header. Okay, cool. Basic auth. It takes the second parameter. It then decodes it. And then it gets the username, the password. It sort of checks them all, makes sure they're all good. And if it's good, it lets you in and you're good. So that's an example of how basic auth could work. Now, the reason why you're probably not going, I want to tell you about basic auth because it comes up and it's easy to implement. So like, it might be something you want to explore if you just want really simple auth on something. But the reason why I say you're probably not going to use it is you're noticing there, I'm sending my password in plain text to the server. And in general, then the server then has sort of the password in plain text, and they're sort of sending it over the web in plain text. Generally, that's not so great. There are ways to sort of mitigate it and work around it. But in general, for that reason, there's sort of usually more complicated auth mechanisms you go through to try to avoid sending data like that in the clear. Is if you're doing this over HTTPS, it's not as big of a deal. If you're doing it over HTTP, though, remember, HTTP, if there's no encryption going on, if you're sending something over the web, then anyone sort of can see that value. And if anyone can see that value, they can get your username and password from there. If base64, you can go both ways. There's no sort of like encryption there. It's just encoding it in a fancy way. So anyway, it's not as used any, and the other reason why it's not as used as much anymore is because it's not all that flexible. Like if you just have a username and password, that's cool, but like you can't really do other things. Like maybe you want like a one-time code from like a phone because you want to implement like a second factor authentication or something like that. Like there's just, it's a not all that flexible system, but for simple stuff, it can work really well. The thing you're probably going to use, though, I would expect, is bearer auth. So bearer auth, the scheme is bearer, and the second parameter is what's called a token. Has Max talked to you at all about what a token is? This phrase come up before.
I don't think so.
Okay, cool. So a token is a unique identifier that's pre-generated by the folks who run the server. Excuse me. It's something that in general, you want to keep secret. And it's something that sort of identifies you as who you are when you make requests. So think about like a house key. If you want to get into your house, you've got a key you can use to do that. And generally, let's say like you live alone, you don't, let's pretend there's nobody else in the picture and it's just you. Like you have the key, and that's sort of how you prove to your house that you're who you say you are. If you give someone else that key, someone else can get into your house. Someone else can sort of access things. So in general, you want to keep a token secret so that other people can't access information that's meant for you. So what do tokens look like? Well, most of the time, they just look like a random series of letters and numbers, sort of nothing all that fancy. Sometimes it can get a little bit fancier, but like in general, it's going to be a not really human readable string of characters. What that token is used for, though, so we already talked about authentication. So verifying you are who you say you are, or yeah. But a couple other things, rate limiting. So let's say there's an API or a service where they only want people to be able to make so many requests. Good example is like, let's say maybe the service is free and it costs the maintainers a little bit of money to run. And they're sort of being generous. They're hosting it for free, but they don't want people to just like abuse the service and make tons and tons of requests. So what they might do is they might force you to make a token, include that token on every single request. And then because you're including that token, you can sort of count how many people, like every single time that person makes a request. And once they get to a certain limit, you might cut them off and say, okay, you've made all the requests you can for now. Come back in an hour and your counter will reset. Something like that. That's pretty common with free or even some paid API services. Actually, some paid API services, they'll use this to sort of tell you how much to charge you. Like if every request costs like 10 cents, this is sort of how they're able to tie that request to that credit card or whatever to charge you properly. Another reason why tokens are important are permissions, so authorization. You might have access to a resource, but let's say you only have read access to it. You can't write to it. And you're making a request that's supposed to write to that thing. Well, you can't, or you shouldn't be able to. If you can, you're sort of able to escalate your privileges, a privilege escalation vulnerability. It's not a good thing. So a token sort of is one way by which you can guard against that and make sure that people can only modify what they're supposed to be able to. Okay. So generally, if in a successful case, you're going to send a header like authorization bearer my token to the server. The server is going to process it. It's going to look up the token, make sure it's all good. And if it's good, you're going to get back a 200 of some sort. On the other hand, though, if it's bad, you're probably going to get back a 401 unauthorized. So 401 and occasionally 403, but really 401 is the better one, is a status code dedicated for this purpose. You have not specified proper authentication information, so therefore you are not allowed to see this information. So if you get back the status code, it means almost definitely something's wrong with your authentication header. You should look at that. In fact, it's common enough where this is a case where there's a code specially for it. Okay. That's all I'm going to talk about authorization for now. You've got an exercise in your homework later tonight that deals with authorization. Out of all the headers we're talking about today, I think this is probably the one that is going to be most pertinent in the near to midterm. So I'm going to put out there any questions anybody has before I move forward. Okay, I'm going to keep going. Again, I realize you haven't actually done anything yet. We're getting there. We got to get through a little bit of the lecture first, though. Okay, location. Have you noticed how we haven't talked about any status codes that start with 3? We also haven't talked about any that start with 1 either. But we've got to talk about 2, 4, and 5. We haven't talked about 1 or 3. Well, the reason we haven't talked about 1 is because the 1s aren't really used. They're sort of, well, they are used, but they're sort of more obscure and aren't used for the day-to-day sort of things. The only one that starts with a 1 that I even come across on any sort of regularity is 101 switching protocols, but that's one that is above and beyond sort of what we're going to talk about in this week. So ignore the ones that start with the 1. The 3s, though, these are actually kind of important. So what one that starts with a 3 means, really there's 2 that are the most important ones, 301 and 302. And these do what's called a redirect. So if you ever gone to a web page, typed in a URL in your web browser, hit enter, and then notice that the URL in the web browser changed. You went to let's say example.com and hit enter, and then you notice the URL changed to be www.example.com or something like that. So what's going on there is a redirect. This is a thing built into the HTTP specification. And the reason why it exists is the people who sort of did a lot of the early work on the web realized that things on the web aren't going to exist in the same locations forever. But that being said, links are sort of a thing people tend to persist for a long time. So they wanted to provide a way by which people could create a means where a link could sort of be mutable, it could sort of change over time. And this is sort of what they came up with. So if you visit a URL, you could get back a 200, you could get back a 400, you could get back a 500. But it's also possible you could get back a 301 or 302. If you get back, we'll start with the 302. If you get back a 302, it's a 302 found. And what that means is it means that actually the data you requested is now located at a new location. So the way that's indicated is the response coming back from the server will have a header called location in it. And that location header, the value of the location header will be the new URL that data is located at. So in the case of our example.com sort of redirect thing, what happened there is you visited example.com, hit enter, and the web browser made a request to example.com, a GET request to example.com. And the server returned back with probably, I would guess, a 301, but let's say a redirect. So a 302 could return back with one of those. And what it returned back with that. And then in the response headers, there was a header called location that was something like www.example.com. So what the server did is it then said, okay, cool, it's located at this location instead. So it stopped its connection, made a new connection, and then it's now reached out to www.example.com. And what you can do sort of here is you can sort of have the web browser sort of like in flight change where it's making a request to. And there's no reason that www.example.com couldn't also return a redirect and sort of redirect somewhere else. So what can happen is the web browser can actually be redirected a few times before it actually gets to the final location of where something's located. So what that facilitates is if you have, let's say, some sort of path to something on the web, some sort of URL, and you maybe change where it's located, and then you change it again and change it again, you can sort of have each redirect sort of point to the next one and point to the next one. And then sort of no matter where you go, eventually after a few redirects, you'll get to the final location. So that's where redirects are used most often. The difference between a 301 and a 302, in practice, they work the same way. A 301 means the redirect is permanent. So in other words, the data, the thing you're looking at, it's changed permanently. Like this URL that you visited is never going to be active again. Why is this important? Well, it means if a web browser gets a 301 back, it can sort of store that locally. And then next time, if you make a request to something that you sort of know you got a 301 back for in the past, you can say, oh, wait a second, I got a 301 back for that. I don't need to make a request to the server again. I can just redirect directly to the location header I got back the first time. So it sort of is like a performance optimization that can often be helpful in these sort of redirect chain sort of situations. A 302 means a temporary redirect. So that's a redirect that the URL or the original URL might become active again. So in other words, it's telling the web browser you don't need to cache this sort of information. So that's what the difference is. In practice, most often, like I would say 80% of the time, you're going to run across a 301 if you see a redirect. So I want to give you a little example sort of in practice of what would happen here. So let's say I made a request to /first. So I make that request and then get back a response from, and then it's 301 moved permanently. And the location header is set to http://example.com/second. So then I'll maybe connect to example.com and then make a request a second. And then eventually after all that, then I'll get back a 200 OK and I'll have some HTML in there that I can render. So that's sort of in practice what the sort of workflow would look like. Okay.
Before you go on, Ryan, so basically the request one is saying, hey, I want whatever is at first, and then it's saying it wants to come back as text or HTML.
It's saying ideally that's what it'd like to get back from the server.
But it's possible it won't happen.
Yeah, and in this case, you're getting back a 301 and saying, actually, this is located at this other location. So in that sort of situation, this is a case where like you've sort of told the server what you'd like to get back, but the server didn't really correctly return that. In this case, it's sort of impossible. Usually when you return back a response as a 300, you don't really give a response body. It's usually just a sort of just some headers. It's just an empty response body.
Thank you.
Yep.
So location and the URL, that's part of the header, the response header.
Yes, yeah. Sorry, I'm illustrating this like I did in the first day, sort of in the raw HTTP text form here. So this is where sort of what we talked about in the first day, where it goes like method, path, version, headers, and then sort of an optional body below it. Yeah, so like this accepts example of a header, the location or example of a request header, location here, an example of a response header, and then accept here is request header. And oh, wait a second, I got content type there in the response. Interesting. That's a little bit weird. I don't think I meant to do that. Nice. My examples are confusing. Always a great way to start the class. Let me get rid of that. Cool. Okay. Oh, also I'll mention real quick, generally, this whole process is an automatic thing that happens in the browser. So for the most part, you don't need to worry about handling 301s or 302s on your own. If everything's configured right, it should just happen transparently in the background. So I bring that up because you notice here accept is included both in the first request and the second request. Generally, if you're making that request, the headers and all the information in the second request will sort of match the first request, with the exception that the stuff from the location header will be substituted. So if you say, I would like to make a request with this special header in it, then the second request will also have that special header in it. It's usually how it works. But these are just minor details. I think in practice, it's in practice, the place where this is most often used isn't for like sort of URLs you're requesting via something like fetch or curl. It's more like you have a blog post and you move its location or something like that. So it's more for like documents and less for like web APIs.
So why did you remove the content type text HTML from the response tool?
I removed it from there because content type's a request header, not a response header.
Okay, thank you.
Yep, that was just a mistake, I think, in there that I made. Cool. Okay. Cookies. I realize today it's going to be a little bit all over the place, but this is sort of an amalgamation of a few days from the previous modules that I've had to, or the previous cohorts that I've sort of had to crush into one sort of all over the place day. So cookies are an interesting sort of thing in HTTP. I'd imagine probably most of you who have used web browsers a decent amount, like you've run across someone who's told you like, oh, clear your cookies. And you've probably been like, okay, sure. And you like click the magic little button in the background in your web browser, and it's sort of maybe like fixed a problem or something. So what is a cookie? Like, it sort of sounds like, I mean, like everyone, I would guess everyone knows what like the physical like yummy cookie is, but like what's like the web, what's a web cookie? So it's a way by which a web client or a client or a server can sort of temporarily persist information on your local system. This sort of maybe identify who you are, do some sort of authentication or authorization, or sort of keep track of state related to your web request. An important thing is it only works in web browsers automatically. So a cookie is something where like in Postman or curl, you could definitely make it work. And we're going to sort of show you how you maybe could do that. But it's not a built-in sort of feature. And it's also in general, in somewhat modern web applications, you won't see cookies used as much. They're a bit of an older piece of technology. But that being said, they have their place and in certain contexts can be really, really helpful. So I bring up cookies in this whole headers thing because there's two headers that go along with cookies, the set cookie header and the cookie header. So the way this sort of whole thing works is the web browser has this thing called, usually colloquially, a cookie jar, which is sort of a funny name for it. You can think of the web browser's cookie jar as like a place where you can store cookies. So what can happen is a cookie, in effect, is a text string where there's sort of a key bit associated with it and a value bit. So you might have a cookie that's called foo, and the value that the cookie is in there is called bar. Cookie names aren't globally unique. It's a bit more complicated than that. But generally, I would say in most web applications, you can think of them as unique. So you can set a cookie called whatever you want, and that's probably not going to conflict with cookies on other websites most of the time. So the way that the cookies work, or the way they work in the web, is let's say I make a request. What the web browser will do when I make that request, if you configure it properly, is it will go into the cookie jar and find all of your cookies. And what it'll do is it'll include automatically in the request a header called setCookie. And this header will contain all of those cookies, like sort of cookie name equals cookie value, space, cookie name equals cookie value, space, on and on and on. So because you're including this as a header to the server can then look at this data and can say, oh, okay, I see you sending some cookie information. It can do with it what it would please. That can include maybe adding a cookie, or removing a cookie, or modifying a cookie. Once the server is ready to return a response back to the user, what will happen is a header called the cookie header will be sent in the response. And that cookie header will have all of the cookies that the browser wants the server wants the browser to save. So this is sort of how the server end can modify cookies. Whenever a request is made, it can sort of return a new set of cookies in the response back for the browser. And then once the browser gets this response back, it will then take all the cookies in here and it'll then set them in the cookie jar. And then the browser then, of course, includes those cookies in any sort of further request. So in general, you see here that the response will sort of contain those cookies that were in setCookie, or maybe a modified version of them. And then if you make another request after that, those headers will be included, those same headers you got back in the last response from the browser in the cookie header. The other thing too is it's actually possible for the client to modify cookies in certain contexts. So sometimes if you sort of set up a cookie correctly, then in JavaScript, you can modify the cookie jar. You can sort of change around what's in there. And that can be helpful sometimes. So how does that setCookie header get added to new requests? It's important to know that this is like a magic browser thing. Like the browser is what's doing this. Something like curl or Postman don't really have a concept of a cookie jar. So if you make a request to let's say some sort of something that returns back that cookie header, what'll happen is it'll return that back. And then the Postman or curl won't do anything special with that cookie header. It'll just sort of like leave it alone. Well, the web browser, though, that'll actually end up in the cookie jar again. So it's sort of this, if you're building an application or building something where the primary thing it's going to be interacting with it is a web browser, cookies can be, in certain contexts, a good choice to store things like authentication information. Imagine you made a request to the server, sort of included a bunch of username and password sort of stuff or something like that. You could, in theory, return back a cookie that was like a sort of special token value in that cookie. And then every single time you make a request in the future, now that browser is going to include that special token value in the cookie. And then all of a sudden, you've now sort of got a way that the server can sort of recognize and distinguish each client between each other and do things like authenticate the client or authorize the client. So it's an option. In general, tokens tend to be used a lot more with sort of the bearer auth with the authorization header. But there's no reason you couldn't implement something like that with a cookie. And in fact, you'll see a lot of older applications, especially like applications in like the early to mid 2000s. There's a lot of sort of cookie use, clever cookie use there. And it's because no other real technologies existed at the time that would let you sort of do this in a web browser well. Because the other thing too is cookies are persistent between page reloads. So if you reload the page, it's still going to send that same cookie value and still, or the set cookie header is still going to be sent, and you're still going to sort of keep track of all that in the cookie jar. So prior to some sort of newer web browser innovations, it meant that that was really the only way you could sort of keep a session active in a web browser. And that sort of maybe explains why, if someone tells you to clear your cookies, why that's an interesting debugging step. Because if you have something like a token in a cookie, or you got information like that identifies you as a specific user in your cookie, and you clear those cookies, now all of a sudden you're presenting yourself to the server as a brand new user. So it's sort of effectively like turning it off and turning it back on again in a way. Like you're sort of presenting yourself as a brand new user to the server. So you've got no sort of associated baggage. You're like brand new. You're sort of back at the beginning of the system again. So, and yeah, I talked about the server can update cookies too. Okay. So before this class, I was considering skipping the host header because we haven't really talked about enough networking for it to really make sense. And I think I am going to do that because I'm not convinced it's going to make sense to you guys fully. Custom headers. Okay, this is the last thing we're going to talk about. Custom headers, if you want to define your own header that sort of is a non-standard header, something like you want to include like a custom user ID in a header. Maybe you want to, something like I don't know, or any sort of custom metadata information you want to include. Generally, you want to format your header starting with an uppercase X and then a dash. And this is sort of a weird convention. But the reason why it's important is, let's say you made a header, like you just included a header in your request that was something called like, I don't know, test, uppercase T test. And then you set the value of it equal to whatever, and you're good, and everything's working. And then all of a sudden, a new version of HTTP comes out, and there's a new header that's been introduced called test. It's a built-in header. It sort of has certain data that's expected. Now, all of a sudden, anyone who receives that request is going to think your header you made called test is an example of that new custom header called test, or that new built-in header called test. So for that reason, it tends to be that like it's a better idea to, when you make custom headers, to start them with this X dash, because this sort of prefix, this X prefix, has been designated by HTTP is that there will be no sort of built-in headers that start with X dash. So it's a prefix that's empty that you can create whatever you want in there. So it's sort of a hedge against future new custom HTTP headers. And generally, it's just a good idea. Things that follow conventions will do this. It doesn't always happen, but if you make custom headers that aren't standard ones, it would be a good idea to make them to follow this convention. So that's all I wanted to mention. And custom headers can contain any sort of data you want. You can have as many of them as you want, any sort of text. It can be a bunch of space separated sort of words like authorization. It can just be one big thing like location. It can sort of be whatever you want. So that's custom headers. Okay. Let's see. How are we doing on time here? Okay, we're doing pretty good. I think I am going to probably just keep rolling then. I want to give you guys some examples for this stuff. The tricky part is these sort of headers often have to be used in the context of other things. It's it's a little hard to make a request that just purely exercises like a header, because some of these headers sort of have nuanced functions. Authorization is the one that's the easiest to sort of give a demo for and to sort of have you do that. And there's a really great example for the authorization header in your homework. So I think what I might do, I'll give you the option. If you'd like, we can sort of go through that homework example, or maybe have you do that and sort of talk through it and then go to JSON, or we can go through JSON and then do them all together. What do you guys think? Any sort of preference?
All together. Yeah, JSON then all together.
Okay. Okay, so I'll keep talking, and then we'll do them all together at the end. Okay, JSON. JSON is going to be a very important topic. Max told me he mentioned it briefly to you folks, but I like sort of, what do you know about it so far?
Well, it's a way to store data.
It's a way to what?
Or a format of data.
Yeah, that's a good way to put it. Okay. Okay, so the way we're going to go through this here today is I'm going to sort of present you a problem that in the end, JSON will be a good solution to solve. We're going to sort of walk through how generally people tend to solve this problem or have solved it in the past without something like JSON available. And we're going to sort of show, like, I'm going to sort of talk through what some of the pros and cons of doing it in sort of this pre-JSON way are. And then we're going to introduce JSON. I'm going to show you why it sort of changes the game and makes a lot of this a lot easier. Okay. Looks like someone, I think Wayne, you might have some background noise.
Oh, crap. Sure.
No problem. Okay. So here's our sort of problem. We want to make a request to the endpoint get/users. And then in the response back from the server, we'd like to get a list of all the users. So the server somehow needs to like take these list of users and encode them in some sort of way, like, because these users aren't just like username. This is like, these are users that have a bunch of metadata associated with them. Things like name, type, either student or teacher, address, city, and state. So we've sort of got a number of these users, and we want to sort of encode each of these sort of fields in a way where that we can get the data back from the server. We can sort of take that response body, we can do some parsing to it, and then in the end, we can then get the data for these data fields for each user, things like name, type, address, city, and state. So there's a lot of different ways we could approach doing this. I'm going to show you a way that often when people first get into software, usually in not a web context, like they're just sort of, they have a problem like this. We've got data that's sort of structured. They need to send it from one place to another. I'm going to show you sort of a way that they often approach doing it. We need some sort of protocol we can use to send data from one place to another. And what they might do is something like pick a character, something like a dash. And what they'll do is they'll just take each of the fields and they'll just put the field, put a dash, the field, dash, over and over. So you sort of end up having this sort of string here where dash is sort of acting as like a character to separate each of the fields you're showing. And then between each user, you have some sort of other character that indicates like, okay, we're done with the user, we're going to move on to the next user. So let's say that other character is a semicolon. So we might have something sort of like this, where we got two users, got me, and then a student named Susie John. And you might have something like Brian Goss, dash, teacher, dash, 201 East Jefferson Street, dash, Syracuse, dash, New York, semicolon. So this first bit here is all of user one. And then sort of you have this next bit here, which is all of user two. So, okay, let's say maybe that you could take that text string, you could put that in a response body, And you can get that back from a server, and you could sort of decode it and do some parsing on it and get things out of it like the first user has a name of Ryan Goss. That's probably pretty doable. In fact, here's some code to do it right here. So let me show you if this works. I would imagine this probably is pretty readable to most of you, but I'll walk through it real quick here. So I'm making a new variable called input, and I'm setting it equal to this text string here. That's the text string of our encoded information.
Ryan, could you zoom in just a little bit?
Oh yeah, sorry about that.
Thank you.
Is that better?
That's great. I'm on a laptop.
Ah, yeah. Sorry, I'm forgetting I'm on my big 16-inch computer here.
Thank you.
So we take our input string, we split it by a semicolon. So split, I imagine you're familiar with it. It's a method on a string that you take a character, you give it a character, and it will split up the input string into an array where every single, it's like delimited by semicolons. So like in this case, users is something like this, where the first user is this, because everything before the semicolon. And the second user is everything this, everything after the semicolon. So you then have users, which is a sort of a list or an array that's too long. It's an array of users. I'm then going to loop over that array. And then every user, I'm going to split by dash. So if I do like user 0 split dash, there we go. We have all our different bits here. So I split it by dash, and I'm just going to print out each of them. And you'll see here we have something that sort of makes sense there. Ryan Goss, teacher, address, Susie John, student, all that stuff. So very cool. I'd imagine that probably roughly makes sense. And this totally works fine. And this is why most people, especially if you're sort of not getting into web immediately, this is why a lot of people sort of end up going down this path, because it's sort of something that you can come up with that'll work. And it works, so it's probably okay. The thing is, let's add a little more complexity, because in practice, these sort of protocols, they end up getting more complicated. Let's say we need to add a new field. Let's say all of a sudden we realize showing the zip code is really important. So we'll add a field at the end. We'll add a zip code here field, and then we'll include that in here in our thing. So we're gonna have like dash, zip code at the end, no problem. Okay. And then no problem here, we can add another line here. We can print out our zip code, and yeah, it still works. I'll prove it to you here. So I'll copy that, go over here, paste it. Still works. We now have our zip code. Everything's great. Okay, no problem. No big deal. What's going on, Ryan? Why are you saying this is like a not such a great way to do it? Well, okay, let's get a little bit fancier. Let's say we need to remove a field. Let's say we don't care about the type anymore. Okay, no problem. We can get rid of that field. So at the bottom there, you can see we sort of get rid of that red bit. We now just have Ryan Goss address instead of Ryan Goss teacher address. Okay, and we can get rid of this bit here. But the thing is, we then have to go through, because we're removing something here, we got to go through and update all of our indexes. So before it was 0, 1, 2, 3, like this was 0, 1, 2, 3, 4, 5. Now that we're getting rid of one, we got to update it so it's 0, 1, 2, 3, 4, like this one's no longer there anymore. And I mean, this works. Like, what's the big deal, Ryan? Like, this works. I'll prove it to you over here. Yeah, it works. No more type. Here's really where it starts to become a problem though. So we're assuming here that the client and server are tightly coupled, that every single time the client makes a change, the server also makes a change, and vice versa. In practice, in the real world, that's not how things work. The client and server are often developed by different people, and often they're not in super tight communication. And it's really important when you make things, protocols like this, they sort of are backwards compatible. So in other words, if I make a change, if you then later on parse that change with like something like an older parser, it still works. Because if you don't do that, it means things that are existing that are out there are going to break. And that's frustrating and hard to deal with. So here's an example of that. Up here, we've got our new format. So notice this doesn't have the teacher or the student in it. It just has sort of name and zip code at the end. So this doesn't have teacher or student, but it has zip code. So you notice this still has 1, 2, 3, 4, 5. That's 5 bits, just like our original thing did, because before we added and we removed. So 5 plus 1 is 6, minus 1 is 5. The thing is, though, here, our parsing code is our old parsing code. So you see the type field is here, and there's no zip field. So you're probably seeing where this is going. But if I take this here, I go over here and I paste this in with our new format and our old parsing code, you now start to get something that's a little bit weird. Name's right. Type is 201 East Jefferson Street. Address is Syracuse. City is New York. State is 13202. So these should all be sort of like shifted down one kind of. And you see the same things going on here too. So you can see like this protocol with scale starts to break down. It doesn't really work as changes are made to different, to client and server sort of independently. So that's sort of one example where this is not so great. That's not so good. I wanted to really make that clear. So I made a slide for it. Here's another problem. Imagine you have, so I'm a bit of a Star Trek fan, in particular Star Trek The Next Generation. And I really like my Captain Jean-Luc Picard. So for that reason, let's say he's now the teacher. Now you're probably seeing where this is going. But if I take this and I parse this, things are going to get a little, things are going to get a little more complicated. So let me go over here. I'm going to update my parsing code here. I'm going to put that in. Does anyone see what the problem's going to be?
He's got a dash in his name.
Exactly. Yeah. So when I run this, name, Jean, type, Luc Picard, address, teacher, it now gets all mixed up again. And in this case, even because we're only looking at the first 5 fields, state Syracuse, we're actually leaving out something at the end. So this is a situation where, like, you could say, like, okay, Ryan, you sort of picked, you're starting to see I picked that dash for a reason now, didn't I? And yeah, sure, you could pick another sort of character and maybe try to make this less obvious. But in the end of the day, because there's a character separating each of these things, there is a character you can pick that would sort of make this parser confused. And that's not a great property, because now these are the sort of things where, like, when you start to have behavior like this can sort of lead to like exploits and sort of vulnerabilities, because you're sort of putting the application into a state it wasn't quite expecting. And that's often a bit of a concerning situation. So, okay, now that I'm sort of showing you all the sort of problems here, okay, well, I had this decoding thing already written here. Yeah, Jean-Luc Picard teacher, yeah, we already went through this. So that's also not good. Okay, how do we get around these problems? Well, you probably guessed JSON's the way we get around these problems. So JSON stands for JavaScript Object Notation. Now, even though it has JavaScript in the name, JSON is not JavaScript. And I want to make that really clear. JSON is its own thing, just like HTML is its own thing or CSS is its own thing. So JSON is a way you can encode JavaScript data consisting of primitives, arrays, and objects. Now, the reason why it's called JavaScript Object Notation is the format you use in JSON to encode all this information is sort of like a stripped down version of JavaScript. So it's similar to JavaScript in a lot of ways. And as we start to get into here, you'll be like, wait a second, this looks a lot like JavaScript. And you're not wrong. It's very close to JavaScript, but it is a different thing. And the reason why it's a different thing, or sort of why that's an important clarification, is JSON, whenever you're sort of dealing with it, it is in text form. It's like a string. And what you do with JSON is you take that JSON text string, which you sort of treat as like an opaque string. You don't really know what's in it. You put that into what's called a JSON parser. The JSON parser is sort of like a magic built-in function in the web browser that takes that JSON, does some stuff with it, and then returns a matching JavaScript version of that JSON. So sort of a JavaScript, I guess I would say, like, definition of that JSON. So in this case below, we've got some JSON. We put that into a JSON parser, and then at the other end, we get something that has a JavaScript object that contains some keys like hello and foo. And I mean, looking at this, you're probably sort of seeing a similarity to JavaScript. And you can sort of do whatever you want on that JavaScript object. And then at some point in the future, let's say you want to send that back to the server. You can then take that and you can put that into what's called a Json Serializer. So usually parsing and serializing. So parsing goes from JSON string text to JavaScript, and serializing goes from JavaScript to JSON string text. So you can put your JavaScript object into a JSON serializer, and now at the other end comes the opaque JSON string. And you can then send that in a response body to a server. And the server can then, on its end, parse it and understand what's in there. So that is high level how you use JSON. And the reason why it's really important is because in general, most web tools these days, they communicate using JSON. So request bodies and response bodies to a lot of web APIs, especially for things like the New York Times, hint, 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 are going to be in JSON. So it's really important you know how to deal with it, how you know how to parse it and serialize it, go back and forth, because it's going to come up a lot going forward. Okay. So there are three sort of main types of objects in JSON. So you're probably familiar with JavaScript has all these different things you can do in it. You can write functions, you can sort of define complicated data structures, you can write loops, write conditions, variables. JSON has none of that. Remember, JSON is not JavaScript. It's its own thing. The three things you can make in JSON are objects, arrays, and primitives. Now, objects and arrays and primitives, these are sort of similar things to in JavaScript. JavaScript has objects, arrays, and primitives, but JSON only has these, and that's it. So a JSON object is a lot like a JavaScript object. It has keys and values. Around the outside, it's got curly braces. The most important part, though, about JavaScript, or JSON objects, excuse me, is that the keys must be quoted always in double quotes, not single quotes. So in JavaScript, you could do something like this, and that'd be totally fine. Like if you wrote this in JavaScript, that's totally valid. This is not valid JSON. You have to put quotes around the key. I'm emphasizing it because this is like a mistake a lot of people make. Keys around the quotes is very important, or sorry, quotes around the key is very important. And of course, if the value is a string, you also have to put quotes around that too. We're gonna get to that in a second. But other than that quotes around the key thing, JSON objects act a lot like JavaScript objects. So they're a key value representation. They are not ordered. And the values can be any sort of value you'd like. So you can have one which is a value of a number. You can have one which is a value of a string. They don't have to match in data type. They can be whatever you want. Keys, however, in JSON or in JSON objects are always strings, which is kind of similar to JavaScript, although it's a little bit complicated. But in general, like you're not going to make like a key in JSON that's like a number. What you end up doing is if you want to represent it that way, you end up making a string that contains the number, and that becomes your key. So in other words, it's a quoted key, like quotes around the number, which turns that number into a string. So, but anyway, like the keys in JSON objects are always strings and always quoted. JSON arrays. So a JSON array is an ordered collection of values. It's a lot like a JavaScript array. So square brackets around it, you have a bunch of things in there that are all comma separated. And every item in there can be any sort of JSON value. I don't really have too much to say on these. There's no sort of gotcha, like they're really quite a lot like JavaScript arrays. The last thing is JSON primitives. So a primitive being something like a string, a number. The thing is, in JSON, there are much fewer primitives than in JavaScript. So a value or primitive can be a string in double quotes, not single quotes, only double quotes, a number, true or false, or null, and that's it. Undefined, you can't use that. You can't use things like infinity or NaN or any of the sort of fancy sort of like values in JavaScript. Like all you have, you've really got quite a limited subset. And that's sort of on purpose to sort of limit sort of the work a parser has to do. But in addition, you can't do things like use operators. Like JSON is much simpler. It just, the values and primitives that are allowed are just what's in the list above here. Constant data, things like constant strings and double quotes, constant numbers, true or false or null. Regular expressions, you can't use those. They're not in that list. You can't use strings with single quotes around them, just double quotes. So there's a lot of limitations with JSON, and I'm calling all this out because there's a lot of gotchas, and especially when folks are getting started, they might do something that they expect to work in JavaScript and it doesn't work. And it's just that JSON's a lot more strict than JavaScript. Another thing that's important, which I don't know if you've been taught, but I want to bring up, is you can't use trailing commas in JSON. So if you have something like an array, you can't put an array, or sorry, you can't put a comma right here, for example. That's allowed in JavaScript technically, but you can't do that in JSON. Danielle, you got your hand raised.
Yes. Okay, you may have explained this, and I apologize for the redundancy. What would be the purpose of us using JSON over JavaScript? Are we only using it when we have arrays, or is it because we're trying to receive something back that is already written in the JSON?
Yeah, it's a good question. So JSON, and I think if I pull up an example here, it might be helpful. Yeah, yep, here we go. So here's an example of JSON. And the JSON primarily is a data transmission format. JavaScript is a code format, like you write software in JavaScript. JSON, you don't run JSON. You sort of parse it and it's used to represent data. So the reason why JSON's important, or why you would use it over JavaScript, is if you want to send data from one person to another, something like JSON works really well for that. But something like JavaScript, imagine like you send someone JavaScript. In order for them to parse that JavaScript, they have to execute it. They have to run that code. And in general, you're then sort of forcing someone to run some untrusted code on their computer. And that's generally a bad idea, or a thing that you would tend to want to avoid as one writing software. You sort of want to trust all the code you're running. So the nice thing about JSON is, because it's so limited and stripped down, when you're parsing JSON, you're not running it. You're just going through it character by character and sort of figuring out, or the parser's doing it, sort of figuring out like what actually the JSON means. So the sort of limited structure of JSON means it can be serialized and parsed and sent between people without having to like execute it. Does that make sense?
Yes, thank you.
Great, okay. So I also wanted to point out that this might be obvious, but just like JavaScript, the values and things like JSON objects can be a primitive, or they can be an array, or it can be another object, and you can infinitely nest JSON. So in this case here, I've got on the outside here, I've got a JSON object that has a key of hello that maps to a value of world. And that value of world is a JSON primitive. It's a string. And I've got another key here, foo, that maps to an array. And that array then contains a list of 3 primitives, all numbers. But the important thing here is like the values in that JSON object can be whatever you want. You could, inside of this array and the key of foo, you could have like the third or fourth item or something be another array or another object. So this sort of means where you can represent things as key value or an ordered list of things. Those are 2 really powerful primitives. And used in combination, you can represent almost anything, almost any sort of form of data. I think I have yet to come across some sort of situation where I've been unable to represent it using JSON. Like it's that good at, even though it's small, it's like that good at representing data. Okay. You guys ready to write some code?
Yes.
Okay. Let's parse some JSON in JavaScript. Okay. So here we go. Here's my little example from before. This is from the slide before the hello world foo 1, 2, 3. So what I want to call out here is, excuse me, inside of the string here, this is JSON. It is inside of single quotes here, inside of the string. The thing is, this JSON, I'm not just like putting this directly in JavaScript. This JSON is embedded inside of a string. So if I log out text, like I'm getting a literal string that contains this JSON data. And this is the correct way you represent JSON in JavaScript. Like imagine you got back data from a server. That data from the server would be a text string and would contain something like this. What you don't want to do is something like this. You see, I don't have the quotes around it. Now, the reason why this is a little confusing is if you hit enter, this is going to work. And it's even going to seem like, oh, wait, stuff kind of did things magically. Like this looks like it's sort of, I can like look through it. Things are like looking good. And the reason why this is working is JSON, because it's a stricter form of JavaScript, it actually can be parsed as JavaScript. So if you take JSON and you set it equal to a variable, it'll work. It's just that what you're doing there is sort of like, it's very similar to just defining an object in code. This happens to have a key of this, a value of this, a key of this, a value of this. Like, but this is not JSON. This is just code in JavaScript that happens to be assigned to a variable. So I want to make that distinction. This is a JSON string, and this is what we're going to operate against here. Okay. Now next, we're going to parse some JSON. Also, let me put this in the chat. So if anyone's following along, they don't have to type this here. Okay. Oh, and Mel's got me too. Christy, you got your hand raised.
Yesterday, I noticed that Stephanie was using VS Code. Is there a way for us, because what we do is we have like, this is week 10, so we have week 10, day 1. So today will be week 10, day 3. And we put our code in, and then that way we can refer back to it. Is there a way for us to do what we're doing through VS Code so that we can reference it?
That's a good question. Yeah, potentially. So I would say probably the easiest way that I know of offhand. I got to be honest, I'm not actually all that familiar with VS Code. It's not something I use on a day-to-day basis professionally. I think though the easiest way might be is if you make an HTML page and you make a script tag in there, and you put all this in that script tag and you save it, and you open up that HTML page in a web browser, it'll run everything in that script tag. So let me actually do that here. I have VS Code open.
We can also make a script.js too page.
Yep, that would work too. Yeah.
Okay.
I have VS Code open for an unrelated reason, but I swear I don't actually use it all that often. So let me do that here, just so I can sort of try to follow along in a way that maybe is helpful for you folks. Okay, so I'm going to do something like script. I'll save this and I'll put it in my home folder and I'll call it careersincode.html, something like that. And then something like that. Yeah, that totally works. Awesome. So hopefully that made sense. So I'll keep going along in here. And I guess this means I can probably send you this file when we're done, which is probably a good idea too. Okay.
Thank you.
Yep, no problem. Glad I can adapt it to make this a little bit nicer for you folks. Okay. So next up here, we need to parse this JSON string and turn it into JavaScript that we can do something with. So the way you do that, there's a built-in function in the web browser called json.parse. So similar to like console.log, similar to set timeout, it's a thing built into the web browser. So what I'm going to do is I'm going to do json.parse. And json.parse takes a single parameter, takes another parameter too, but it takes one required parameter, text. And this is the JSON string to parse. So this is a string, keep in mind. This is not a JSON like raw, like this wouldn't work. It's got to be a string. Okay. So data, something like that, I'll store into data. I'll just console.log data, something like that. Okay. So I'll save that, reload this here, and there we go. We have something that looks sort of like a JavaScript object. So what json.parse has done is it's taken this text string here, this whole thing here, it's sort of done its magic on it, and then out the other end has come this JavaScript object version of it. So one thing I'm going to do to really sort of drive this point home, over here, I'm going to go json.parse this text string like this. And you can see this is a text string going into json.parse, but at the other end is a JavaScript object. So that's what json.parse does. It is the parsing end of the JSON sort of toolkit in the browser. So you could imagine if you got back a data from a fetch request, like you did response.text, you got back your response body, you could run json.parse on that response text. Instead of just logging out immediately, you could run json.parse on it, and then you logged out the thing you parsed. And now all of a sudden, you're logging out the JSON object that came, or the JavaScript object version of the JSON that came back from the web server. So that's a pretty common thing you do, something like that, like parsing JSON that comes back from a web server. Okay, the other end though, oh yeah, I was going to show, so because this is a JavaScript object, you can sort of do whatever you want with it. You can do something like hello, data.hello. So if I do this, data.hello is world. So locking out world there. That's what data.hello is equal to. I could also do something like data.foo0, which if anyone has any guesses on what that would be. But if I reload the page here, yeah, 1, because data this whole thing, dot foo, this key, which maps this value here, 0 bracket 0 bracket. In this array, first element, 0, is 1. So once you've parsed your JSON into JavaScript, you can do anything you would do with any sort of native JavaScript data structure on it, anything like this. Okay. Where am I here? Okay. Encoding, going the other way. So obviously, once you've parsed something, you probably need a way to convert it back into JSON again. So I'm going to do this. I'm going to go console.log parse example. Console.log stringify example. So if you have your data here and it's hello world like this. Now, if you want to take this and convert this back into a JSON string, the way you do that is a function built into the web browser called json.stringify. Now, notice I was using the word serialize before. It's typically what you'd say, like serialize JSON back into a string or something like that. The web browser, they call it stringify. And I guess you could say stringify it back into string. Like, I don't know. It's just sort of what they picked. It's a little bit weird. But I guess convert back into a string, I guess it sort of makes sense. So I will give put data here and log this out, something like this. And I'm going to save that. Go back over here and reload. You'll see it's now given me this JSON string. Now you'll notice one difference between this JSON string and this JSON string is that this one doesn't have spaces in it. So notice here you've got like colon space, and here it's just colon and no space. Now, there's a reason that is, and that's that white space in places like this, just like in JavaScript, is sort of optional. So when json.stringify generates the JSON, it will give that to you in sort of the most compressed form. And that's just because JSON is often used in a machine readable context. And when you're sending it between systems, less bytes means less time to send it. So it's often done that way. Yeah, and I think that was all I wanted to show for Stringify. Yes. So let's talk about the JSON version of our example, because we can sort of rebuild this using JSON. So in this case, we now have an array with 2 objects in it. And you see these objects sort of match the same sort of format. They each sort of have the same keys. And the values are all sort of similar. And you can see we have sort of name, address, city, all that sort of thing. And I can do something like users example. So I've got my JSON, big JSON string here, which has a lot of white space all over the place. So I want to make it easy to read. Then when I go over here and I run this, you'll see, oh, well, I didn't get a syntax error. Where does that? 14. Yeah, somewhere in here. Got a smart quote somewhere. There we go. There's our smart quote right there. This is the problem I think Stephanie ran into yesterday. Freaking smart quotes. Okay. Yeah, there we go. Let me fix that. I copied and pasted that from slide 139. Okay, let me.
How do you know it's a smart quote versus a regular quote?
I've gotten really good at picking them out over the years. if you look really subtly, this quote right here, it's sort of like curly.
Yeah, I see it.
Compare like this to this.
I
So
see it.
yeah, it's just like a little goofy. 139. Okay. Yeah, I think I got them all. Okay. Anyway, though, over here, though, you can see I'm parsing this, and then I'm getting data 0 name. So data 0, this first object, dot name, this key name, this value, Ryan Goss. So save this, go over here, run it. You saw Ryan Goss, got what I expected. So this sort of pattern, an array of objects, is very common. Anytime you're representing data that often is like tabular in form, we have a bunch of sort of like headers for a bunch of rows, and you've got a bunch of, or headers for a bunch of columns, and you've got a bunch of rows, often can be represented really well in this sort of format. Every item in the array ends up being a row, and then every key and value ends up being a column. Yeah, so this is pretty common. In the sort of case for adding and removing fields, so in this situation here, I didn't have that type field. And you can see that when I run it, oh, Stephanie, raising your hand.
Sorry, I have an error on line 22. I don't know if I copy pasted the code wrong. Do you mind showing your VS Code again so
Yep.
I can see where the error is?
Let me see if I can make it a little bigger here, though.
Line 22. Huh. Do you mind if I share a screen really quick?
Yeah, go for it.
Okay. So let's see. Bring my screen back. So it's giving me this.
Okay, so it looks like, so it says your error is on line 12 of index.html, I think.
Oh, line 12. Oops.
Yep, so the Json Parse. There's something in there. Take a look at the I think you might have some smart quotes in there still. If you take the quote at the very beginning of line 14 and you copy that, or, oh yeah, actually, you see how you got you're selected and it's showing you all the matches? Notice all the quotes except for one are matching at the very end on line 25.
Oh.
That's a smart quote. I bet if you save that and run it, it's going to work. I really hate those smart quotes. Yeah, there we go.
Okay, thank you.
Yep, no problem. Actually, Mel, I think in the thing you pasted, you've got a smart quote at the very end. Just FYI.
Yeah, I noticed that. That's why. Yep.
Cool. Okay. Share my screen. Okay. So doing this whole add and removing field thing, let's sort of go through that here. So comment this out here and we'll go down to, and by the way, I think you folks know this, but Control/ will comment out all whole selected block in VS Code. Kind of a handy shortcut. Okay, so we're going to do add remove field example. So in this case, gosh, so many smart quotes. Okay. I swear I went through this and like fixed all these. So I'm sorry. Okay. So let's say we remove the field type. So I'm going to take that out, and we run this. What we're going to get is undefined. So if a field doesn't exist in a JavaScript object, the value that you get if you look it up is undefined. So what's nice here is at least we're not getting incorrect data. We're at least now getting something that says that field doesn't exist. So if I have code that expects that field to exist, what I can do is I can be defensive and I can check to make sure it exists before I use it. And in general, that's not too bad of an idea to do with APIs you don't have a ton of control over. Sort of be a little defensive about it. And assuming that that field does exist, you can do whatever you want with it. And if it doesn't, you now have the ability to handle that error in sort of a nice, concise way. So that sort of is one example of like sort of how the JSON solves the problems with our sort of bespoke data format. Okay, we're almost done here. So JSON is an untyped, and that's a really important distinction. Other serialization formats, there's sort of a guarantee about exactly what fields you're going to get back, exactly what format it's going to be in. In JSON, it's just sort of like whatever the server defines or whatever sort of you, the client, send to the server. So you could include, like the server might expect you to be sending an array of a bunch of numbers. You could send the server an empty object, and that's totally valid JSON. There's nothing explicitly defining that format. Like, so the server would just receive that empty object and would sort of have to handle that. Probably would give you back a 400 or something, but that's totally a valid thing to do. Other data formats aren't as prescriptive. Like, in order to actually encode the data format, you've got to give it all the sort of bits, and it's got to sort of pack them together in a very specific way. So this is how, like, the sort of pros of being untyped is because it's flexible, it means the client and server can often be completely independent. But it also means that things like our type example can happen where fields that you might exist don't exist. So it's a bit of a trade-off. JSON, though, sort of picks a point in that trade-off that I think is relatively healthy. It allows you to sort of make modifications without requiring both ends to agree. And it also does it in a way where it's sort of easy to handle and easy to work with. So other people might have other perspectives on it, but I happen to really like the sort of balance JSON has chosen to pick. So it's sort of an example of that. We've got this sort of JSON document right here. This is a valid JSON document, and this could be a valid JSON document. And your sort of code might have to handle both of them. Like, you can't assume that sort of this array has all numbers, because it might not. Okay. One more thing. I realize we're sort of getting approaching here on to when we should be taking our break. But this is one last thing for today, and then we're going to get over to the homework assignment. We'll take our break, and then we'll do the homework assignment. Fetch has built-in JSON support. So it's such a common pattern that you get data from a web server and you sort of decode it as JSON, get data in the response and decode it as JSON. That's so common that it has it built in. So yesterday we were doing things like this, where sort of you make a request, you then take a look at the response, maybe log out the status, then get the response text content, and then maybe wait for that to sort of get decoded and then log it out. And this totally works, what we're doing yesterday. But if your endpoint, your thing you're requesting returns JSON, you'll notice here this thing we're fetching here is different from what we were fetching yesterday. And if I put it in a web browser, we'll see what comes back here is actually some JSON. It's not some just plain text. Or maybe I'll do it in Postman too, just to be rather thorough here. So make a request there, I'll click send. And what I get back here is JSON. I can pretty print it if I want, but at the end of the day, it's just compressed JSON. So I want to somehow take that JSON and I want to get it as a JavaScript object so I can do things with it. Maybe I want to take a look at all those numbers, for example. So one thing you could do, and probably the easiest place to start, is, okay, well, you just take the text you got back, you run it through json.parse, you get the data, sort of similar to what we were doing before. And then there we go. We got our data. We can log it out. Everything's great. So in this case, data is not a string. Data is probably an object or an array or whatever that JSON data parses into. This is fine, but what if we could make this nicer? Because we can. So it turns out there's a method on response called JSON. And if you call it, what it will do is it effectively does the exact same thing as this. Only it returns that data directly in the promise. So before here, we got back text and we had to parse text and turn it into data. In this case, it's just getting back data right away. So this is kind of nice because it's sort of a step you can skip. You don't have to necessarily run that json.parse. I would say it might be good if you're sort of struggling a little bit with this and you sort of don't want to take all the shortcuts right off the bat. Like, this is totally fine. There's no reason why this is bad. It's just, this is cleaner and probably is what you're going to see in more, I would say, like professional code or code used more, or code written by folks who are maybe more experienced. So that's it. Any quick questions here about JSON? Probably should have asked that earlier before I went off on all this fetch stuff, but.
Not at the moment.
Okay. So I think then we're, just gotta. Okay. Yeah, I think we're about ready to take our break then. So it's 7:12 right now. Maybe let's say like come back at like 7:45. Wait, do I have that right? That's 30 minutes. I want to do 20 minutes. 7:30, let's say. Yeah, that would work. 7:30. Sound good? Okay. Sweet. See you folks then. Okay, folks, should all be coming back here pretty soon. So the rest of the class is just working on the assignment. So Mel posted it in the chat. I will also post it here in Slack just so everyone has access to it here. Okay, it should be in Slack as well. And it's in Canvas and the assignment should be ready to go. This is the first assignment here that has some optional next steps in it. So this is a thing I started doing in the last cohort that went over kind of well. So every exercise has sort of a main section. And then at the very end of the exercise, there's some optional next steps. And sort of the way this works is the only required thing is that you do the main exercise. However, the optional next steps there exist for a mixture of the satisfy one's own curiosity and also because some folks might be a little bit further ahead than other folks. So the goal here is sort of to give folks who are a little bit further ahead something that challenges them a little bit. And for folks who are a little bit further behind or aren't quite following quite as tightly, just not to overwhelm them as much. So it's trying to tailor the assignment to sort of a larger sort of width of band of students. Yeah, but in general, this is the first time we have that has a little bit of software writing JavaScript in it, so that'll be kind of fun. And the first exercise is all about the authorization header, so it'll give you a chance to really give that a shot. But yeah, and then the final exercise, exercise 6, that one's going to be a little bit fun because it's going to be a little bit like the one we did yesterday, where sort of making a request and logging out the response. Only today, you're actually going to do something with that response body and try to log out a sum of a bunch of numbers. So yeah, should be kind of cool. Anyway, feel free to get started. Mel and I are around. And if you have any questions, don't hesitate to ask.
Question.
Yeah.
So I'm reading through this and it says in the JavaScript console, are we going into like Chrome and then going into the console, or can we write it in the VS Code like we usually do?
You could write it in VS Code just the same sort of way with a script tag like we just did earlier. That would work too. Really,
Okay.
you just want to run it in a place where you can run JavaScript.
Okay. And so in VS Code, there's the HTML and there's the script.js. Would it be better to use the script.js or index HTML and then put the script tag inside? Like, does it make a difference?
It shouldn't make a difference. So do whatever's more comfortable for you if you want to do it that way.
Okay, and then because when we go live with it and then we go into and it takes us into Chrome, then we can go into inspect and go into the console. So it would give us the same results.
Exactly. Yeah.
Okay.
The only thing I would say is if you do it that way, it might be helpful if you include the script that you wrote or a screenshot of it or something, just so I can take a peek at it. But other than that, yeah, totally fine.
Okay. Thank you.
Yeah, no problem. Zachary asked, what token do I input for the first exercise? So the first exercise has two parts. So sort of the post/tokens and this get to /protected resource. So the first part, when you make a post to /tokens, that generates for you an API token. You should get back in the response an API token. And you should be able to include that token in the second request, and that should properly authorize the request. Did that work for you?
I haven't submitted that yet. I thought it was in Postman.
Yeah, you should be doing it in Postman.
But I just create a token in careersincode.ml.
Yeah, so the first request in that exercise, you make a post request to /tokens, and then the response back from that request contains a token. So in the response body, there should be sort of a random letter and number looking value that says, this is your token, it's this thing. So you should be able to take that value, copy and paste that, and put that into the second request to get protected resource or whatever it is, something like that. And include that in the authorization header as a bearer token and sort of the way we talked about in class. If you do that properly, the response should come back. The second request, the response should come back with a 200. Does that make sense?
I'll share my screen, Ryan.
Yeah, go for it.
All right, so I did the first part and I got my token back.
Yep. So if you were to take a look at the presentation, remember the authorization part there's two sort of parts to that header. There's sort of the scheme and then the value. So in this case, it's a bearer token. You notice in the second part, now with this token, make a request to get protected resource using an authorization header with a bearer token in it. So do you remember sort of how bearer tokens work? Not, I can pull up the presentation again.
I got the token right here. I looked at the presentation and didn't really change anything for me.
Okay, let me pull it up. So if I jump back over to here, where is it here? Yeah, here we go. So we take a look here at sort of a successful example. So go something like authorization, bearer, and then your token. So there's sort of a scheme part and a value part, sort of two words in that authorization header value. So for a bearer token, it starts with bearer, uppercase B bearer, and then space, then your token. If you're
Okay.
doing something like, if you're doing something like basic auth, it would start with basic and then sort of that username colon password thing we were talking about. But the whole like scheme value part is important because the server might support multiple authorization schemes. So you need to tell it which one you're going to use.
Oh, okay. Thank you. It
Yep.
worked.
Cool.
And Ryan, we do that in headers in Postman.
Yeah. So there should be a should be able to enter an authorization header in Postman. Are you having trouble there?
Oh, so, but not under headers, because there's a separate thing called authorization. Is that where we do it?
Yeah. So good point. So I should have brought this up. Postman. Let me share my screen. Postman has a tab up here called authorization. And what this will do is it'll allow you to sort of like configure a bunch of different auth things. So you can actually select bearer token here and put in like my token, something like that. And if you go over to headers, it will actually auto-populate to that authorization header for you. It'll like Postman's pretty fancy and it has like a lot of sort of crazy things. So you can do that. You're welcome to. That being said, it's probably more sort of involved than you really need to get. And you can just enter your header right in here, and that works too. So this authorization tab may or may not be more trouble than it's worth. Is that helpful?
Yes, thank
Cool.
you. I think the problem was I had post and not get.
Ah, okay. Yep, that would do it.
I don't know if anybody else was confused by this, but today is actually day 4 of week 10. We didn't have a day 1. So some stuff says day 3 and day 2, which it is the day we were with you, but in our normal range week. I don't know if anybody else noticed that. I just did. And it was confusing me a little bit.
Yeah, I'm going to be back with you folks again next Monday. So I do get a full 4 days, but yeah, it got a little offset. Which I think will be good because we're going to have some office hours this weekend and we'll sort of get a chance to sort of talk through all of this stuff. And then on Monday, we're just going to introduce the last little bit, which is pretty much the New York Times API project. And then I give you a chance to sort of work on that. So anyone who's like really lost, definitely recommend coming to the office hours this weekend.
Can I share my screen?
Yeah, go for it.
Oh. There you go. So it says, please add an authorization type. Or should this be lowercase?
It's a good guess, but take a look really closely what you typed there. You typed bearer : space token.
Yeah, that's not it.
It's not it. Look closely at the presentation. You're really close.
I think it might be a little bit confusing, Brian, because in some places it has like, and in other, when you showed it on the one slide, it didn't. So.
Yeah, I see what you're saying. Doug, if you take a look at slide 90, take a look at that header right there. What's in blue right there.
Oh, okay. Okay.
Yeah, I can see where that might be confusing though, because I put bearer : in a few places in sort of the prose of the slide. Yeah, that might be worth revising. Thank you though.
Thank you. Yes, that's exactly where I was confused.
Cool. Stephanie, I see you got your hand raised. Stephanie, you have your hand raised. Maybe, oh,
Yeah, I honestly don't know where to start. I'm on exercise 1 and I don't know how to begin.
okay. Well, to start with, you're gonna have to make some requests with Postman. So if you don't have Postman open, get that open to start with.
I got it open. Oh crap, where'd it go? Okay, I got it open.
Okay, so you're gonna have to make 2 requests. There's sort of 2 bits as part of that exercise. The first bit, there's an endpoint that exists in the server at post/tokens. And when you make a request to that endpoint, it's going to give you back a token, an authorization token. It's sort of give you a token to sort of prove that you are you. So that's the first step. You got to make a request to that endpoint and get a token back. So think back to sort of what we did earlier on in the week, making a request to an endpoint or a URL on careersencode.ml. So there's a few bits in there. It's a post request, it's the /tokens, and sort of with the context at the top around sort of the server's domain name and the protocol, you should probably be able to put together the whole URL there.
I like I said, I don't know.
Okay, well, what parts are in a URL? You have sort of the protocol at the beginning, the HTTP part. You've got sort of the domain name part, the like careersencode.ml, the example.com, that sort of part. And then at the very end, you've got that path part. So something like /fruit or /JSON or something like that. So you have sort of those 3 parts you need to put together in the URL box. So for this request, got the path /tokens, got the domain careersencode.ml. We've got the protocol HTTP. So the first 2 at the very top of the document. Server's domain name is careersencode.ml. We're connecting to the server, use the protocol HTTP. So the protocol, domain name, the path. So if you put all those together, you should be able to get the URL or put together the URL.
So then I'm just putting careersencode.ml/token next to post.
Yep. And tokens plural, but yeah. I will say, to be clear, with this one, I still like before I was sort of really sort of giving everyone all the sort of little details for each request. I'm starting to get a little bit more abstract because this is the sort of language you'll start to see more when people talk about requests. They sort of leave things out that aren't really included. But how did that go? Did that request work for you?
Yeah, it says your token was created, but then I don't know.
Okay, well, if there's are there any questions in particular have for me, or are they just sort of in general just sort of lost right now?
Yeah, just
okay.
In general lost.
Okay, let me do this. Danielle's got her hand raised. I think she might have a targeted question for me.
Yeah.
Let me let her ask her question, then I'll come back to you when she's done.
Okay.
Cool. Oops, I muted myself. Danielle, what's your question?
Okay, so my question is more so surrounding purpose, because it will help, I think, me to grasp the understanding for why we're doing this and making these requests. Now, I've used token apps before, such as like, I'm trying to think of one off the top of my head, but I can't right now, like VIP access. I don't know if you've ever heard of that, but I've used that kind of app before, which is a token request. And my question is, are we using this to make that sort of application, or is this something that we're using continually whenever we make a request?
It tends to be something you use continually whenever you make a request. So usually what happens is through some sort of mechanism, you generate a token. That could be going into sort of a web tool somewhere and clicking a button that's like generate token. It could be making a request to an endpoint like we're doing here to generate a token. It could be a lot of different things. But then after you've done that, then you include that token in every request to sort of say, this token identifies me as who I say I am, and it identifies me as the same person who's making all these requests. It means I have certain privileges, I can access certain things, I've got certain permissions.
Okay, so I guess what I'm getting at, are we only using it if we're accessing like sensitive information, such as databases that may contain, let's say, health information? Or are we always using these tokens, like no matter what type of information we're accessing, even if it's something that is public?
I see, usually the former. So it tends to be information that is truly public that anyone can access and there's no sort of privileges associated with. It tends to be that that information doesn't require a token. And when you're making a request to a URL in a web browser, there's no token being sent there. Like it's just a plain request. So something like if you're making a web request to google.com, that doesn't require a token. If you're making a request to like example.com, that doesn't need a token. Really where you need a token is when you're requesting something that is of importance or of like secrecy or that only certain people should have access to.
All right, thank you.
Yep.
So is that like a VPN, like when you work somewhere and in order to log into their server, you have to have like something that generates a token? Is that what?
Yeah, it's conceptually very similar to that. And in practice, probably what's going on behind the scenes is the thing that generates the token sort of communicates with the VPN software. And every single time the VPN software sort of connects and sort of sets up that connection, it includes a token. This whole token thing is just a common practice sort of in web security. It's a common way to sort of handle the problem of like identifying who users are in requests.
Okay. Yeah, with the last job that I had, we were able to generate tokens on our cell phones. We had an app that was on our phone, and then each time we got ready to log in, we had to use a token to okay.
Yeah, one-time passwords. That's a special fun kind of token. If you're curious, what happens there is if you have like, imagine you have a thing that can take the date and convert that into a token. So what's going on there is like your phone has the date, a server has the date, and you can sort of use a function to generate a token based on that date. So you generate the token, you type it in, you hit enter, you log in, and then to validate that to make sure it's the correct thing, it sort of is comparing against the date. It sort of takes the date, puts it through this function, generates the code, and makes sure they match. So
Okay.
yeah, anyway, probably more than you want to know, but it's kind of clever. It's a cool little algorithm.
No, I just wanted, because so token is something that is going to be ongoing because most times it's not just information that you want to go across that everybody can read. So we probably need to become very familiar with tokens.
Yeah, and this is something where I'm just introducing them now, but in further modules, you're going to talk more about sort of the security implications of them and where they're sort of helpful and used and things like that. I think Nathan's coming back for a DevOps module in a few weeks, something like that, and he'll get into it.
Okay.
And once you talk about web servers, you're going to end up talking about them too. So, yeah.
So this is intro to tokens.
I suppose it's more like you have to send them over HTTP, and because no one else is going to talk about HTTP, like I'm the one doing that, I kind of got to cover it. And I guess ideally someone would have brought them up before this, so it wouldn't be the first brand new, hey, tokens are a thing, but that didn't happen. So
okay.
As much as you might hope, instructors with careers in code don't really communicate all that well with each other. So we don't really know what everyone else is teaching. And we try our best to try to cover the bases, but often don't. So, yeah. Cool. Larry, I see you got your hand raised.
Yes, I need to share my screen again.
Sure.
Okay, so I went to add the new label as an object, and I'm getting these errors here.
Wow,
And
fancy running it with Node. That's totally fine, but I just wasn't expecting that. Cool. Yeah, so you can see there's all those little squiggly red lines. Those are probably a bad thing. What I want to draw your attention to is on the left side, you've got sort of the line numbers there. And if you notice how sort of the first line is let JSON string equals. The second line sort of starts with a single quote, has sort of the bits in the JSON string. And then after that, the third line is sort of a bit more of the JSON string, and then a single quote, and then a semicolon at the end. So I don't know how much Max has talked about strings, but an important attribute of strings in JavaScript, at least single quote strings, is that they be on a single line. You can't have them spread across multiple lines like that. So you need to make sure that it's all on one line, or you need to switch to a different kind of string that allows you to have them on multiple lines. Yeah, like that. So I bet if you save that and run it again, that'll at least give you a new error, if not work.
thank you.
Yep. Okay, Stephanie, if you have any more questions and you want to run through something, more than willing to do it. In general, I feel like if you're a little bit lost, there's probably some other folks that are lost. So I'm more than willing to sort of do maybe an introduction or run through of something I maybe talked about earlier in the week, if that will be helpful to get you unblocked.
I'm on exercise 2, and is there a slide I can look at to figure out what I'm supposed to do?
Yeah, exercise 2. So that's the one with JSON parsing, correct?
Mhm.
Okay. Yeah.
It says, yeah, convert the string into JavaScript object.
Cool. Yeah. Let me share my screen here. I would say probably the most relevant slide. Sorry, we had a lot of slides today, so I gotta jump through here and find it. Yeah, here we go. So we've got this section here about parsing JavaScript, decoding JavaScript, and encoding JavaScript. So this is slide 137 and 138. I think these are probably the most straightforward examples on the sort of thing you need to do for assignment or exercise 2. In particular, I think the JSON decoding would be a good place to start.
Okay.
Cool. Let me know how that goes. And if you have a question, I'm more than willing to talk more about it.
When are office hours?
That is a good question. How does Max normally figure that out or organize that?
We take a poll.
Okay. In Zoom or in Slack or?
he creates it. Like he has this little quick polls that just flash across our screen. And then
Zoom.
he just,
Zoom.
In Zoom? Okay. I gotta be honest, I'm not as good at Max with Zoom. And if I go into polls, I don't see the poll that he normally uses. That's not something I can just like click and make show up. I don't think. Class exercise, class split. Yeah, I don't see it. And it might just be that I'm kind of inept at Zoom, or it might be that like he made it locally on his system or something and doesn't share it with me. How about this? Let me make a poll in Slack after class. I would just sort of propose some times, but I've got a bit of a commitment potentially today or potentially on Saturday, and I need to sort of confirm it on my end to see. Do you normally, are they normally on Saturdays or Sundays, or what's like the time they normally are at? Or is it they're not really a normal time?
most recently it's been Sunday at 5. But this past Sunday, I think there was a miscommunication, but since everybody is still here.
Okay. I will say I can probably make that work, but is it okay to just have an informal, like, would 5 at Sunday not work for anybody?
Can they hear you?
I could make that.
hopefully.
Should we raise our hand if it doesn't work or if it does?
Yeah, raise your hand if it doesn't work. Okay. I mean, I'm not seeing any hands raised, but I guess also if folks aren't listening, then they're not really going to get a vote. So I guess that's a downside of just doing it informally here. Let's do this. Let's plan on that. 5 p.m. on Sunday. I will post a message in Slack about it. And if I get folks being like, wait a second, that's not going to work for me, I'm super worked up about it, like, we'll figure it out. But I'm like 95% sure that that'll work for me. You might have noticed if you're looking at my clock on my computer, I'm on the West Coast right now, so timing's a little bit interesting, but I think that's on the right side of timing to work for me here.
What time is it where you are?
It is 5 p.m.
So Sunday, that would be 2 p.m. for you.
Yep.
Okay.
Zach, got your hand raised.
Yeah, can I share my screen?
Yeah, go for it.
What am I looking to get back as a response for the second exercise?
For the second exercise, yeah, let me take a
Oh.
peek here. So for exercise 2, to convert this string into a JavaScript object using the native JSON tools in the browser. So sort of I mean, what you've got there largely looks right. Does that run for you? Invalid or unexpected token at CIC 61.
Oh, I think I might know what no, that was in Postman.
Go back over to VS Code for a second. So in general, I'm looking at this, and I'm seeing a lot of sort of bits where there's red squiggles. And that to me means there's probably something formatting wise going wrong here. And if you take a look on the left side, you see 61, 62, 63, 64 like that. You have it sort of similar to Larry before. You've got a string here that's separated across multiple lines. So you got a couple options. You can either sort of smush it all together on one line, or you can change the kind of string that it's in into a kind of string that supports multiple lines, like the backtick string, for example. I think you folks have learned about those.
Yeah.
Cool. So I have a feeling if you do that, either of those options, and save it and reload it, it's just going to work. Yeah.
So this is good for return?
Yeah, I mean, I
Okay.
think so. Looks like data that came back. That, I mean, does it look like the JavaScript version of the JSON object?
Yeah.
Cool. Then I think you're good.
Cool. Thank you.
Yep.
Ryan,
Yeah. How's it going, Larry?
going pretty good. For exercise 3, for the optional steps, when it's saying that JavaScript smushes everything together for the JSON object on the one line. I know there's like stuff that makes it prettier, so it looks like that. Are we supposed to use that, or are you asking us to do it programmatically?
Oh no, I'm saying look it up online instead of how would you tell JSON.parse to do it for you? Yeah, I mean, you could try to do it yourself manually if you want to, but that's like way above and beyond.
Basically, use a JSON parser, right? Or a raw.
Yeah, I mean, you sort of have to start to write your own JSON parser, which is a fun problem, but probably not something you want to do right now.
Right. So basically, I just need to answer the question.
Yeah, as a hint, if you look up the MDN page for JSON.parse, it's going to be probably pretty obvious on there how to do it.
All right. Thank you.
Yep. So I want to call out, Mel mentioned in the comments, you can install a code formatter in VS Code called Prettier. Prettier is actually in a lot of different editors, and it's also sort of standalone too. It's sort of one of the standardized JavaScript code formatters. So if you sort of want some help making your code look a little bit nicer, it might be worth investigating. I use it not in VS Code or a different editor quite a bit, and I do like it quite a lot. So. Oh, you have Prettier.
Yeah, we
Awesome.
use Prettier. Prettier can be also sometimes annoying.
It can. Yeah. Cool. I will say, for what it's worth, I don't use it in the mode where when you save, it automatically formats. I format separately once I'm done and ready to sort of see all that churn.
I had to turn that off.
Yeah.
Right. I guess I don't understand the answer Did you, or I don't know, messing it up. So I know that like there's extensions and stuff that you can use to make the raw JSON look pretty, like how you want it to look. Is that what you're asking, or are we supposed to actually do something to make it look pretty? Because I'm kind of
There's
lost.
well, let me show you. So I'm going to go to the json.parse page on MDN. Scroll down here a little bit. Or wait,
Yeah, because I went there, I didn't really.
this is exercise 3, right?
Yeah, 3, the
Okay,
option.
I meant json.stringify, not json.parse. I was looking at that and I was like, wait a second. Yeah, that doesn't have the parameter. Yeah, json.stringify. So
I'm
stringify
talking
is
about for the optional step though, because I got the stringify thing taken care of.
Yep, yeah, for the optional next step. So if you want to take this and format it as a string that looks like this, so going from JSON or going from JavaScript object to JSON object, that's stringify, not parse. So
Okay.
if you go
Thank you.
here, here's your really overt hint.
Thank you. I was reading through the documentation, but thank you.
Cool.
Right, it kind of worked, but it did something weird in the sense that um, each value in the array for counts is also put on a separate line as well.
Yeah.
I got the same thing.
Yeah, so what it does is it doesn't format anything on the same line and do it that way. I think hopefully if I was not, no, I did, that's totally a fine answer to the question. I need to update that example to, I'm gonna do that right now to make those all in separate lines. That's, in practice, that's what you're gonna get.
Can you repeat that last part in practice?
In
So
practice,
it would look like, okay, so you're going to change the example to look like what we got.
yep, if you refresh your page, it should be updated.
Okay,
Yeah,
thank
you did the right thing. It's just I was typing it quickly and typed it wrong.
I have a problem.
Yeah.
So when I tried to, and I've been trying to fix this, but when I try to go live, it's saying console error, upgrade your browser. This browser is not supported. WebSocket for live reloading. What does that mean?
I would guess, so that when you're opening up that HTML document, how you're doing it, you're starting some sort of local web server.
For go live. Oh, because it's HTTP. Is
That
that
could
one?
be. Can you share your screen? I'm curious to, I think I know what's going on, but I just want to verify.
Okay.
Can you go to the JavaScript console? And refresh the page. Where are you seeing that error?
You didn't see it before I refreshed?
No, it looked like it just said live reload enabled and that's it.
All right, let me try it again.
Well, what I will say is either way, like it's not that important and it shouldn't affect the exercises we're doing today.
Of course it's not doing it now that wait, here it is. Live, see where it says live reload enabled?
Yeah, so what's going on there, I'm not exactly sure what the web server you're starting is locally, but most likely it implements a thing called live reload. And this is sort of a technology where you can sort of save your web page in your editor and it'll immediately reload in your web browser. So you don't have to sort of sit there and like save, go over, refresh. It's kind of handy. It's handy, but it's not like critical. And the way that works is behind the scenes, the web server you're running sort of just like looking at that file. And when it notices it changes, it sends a message to the web browser and tells it to reload. And there's sort of some custom JavaScript that runs in the web browser to make that work. And I would guess the error you're seeing is it just sort of misbehaving, or in the case where live reload sort of enabled, like it's just printing out live reload's enabled and it's working. But if you see some sort of error related to something like that, it might just be live reload isn't working. Like in practice though, whether or not it's working or not, like you're still going to be able to run all the exercises. Yeah, you should be okay.
So
worst
can
case,
can you see right here where it's saying where it says that message, because it's not letting me see what I'm putting into VS Code. That's because I'm going here to try to see.
Can you go over to your Elements tab and open up the body?
Where's body? Right here.
Yep. And then go into the script at the very top. Okay. So it looks like what you've entered in VS Code is being run. It's just you're not seeing anything because it's not doing anything with it. So you sort of you created a new variable called JSON string, and that's all you did. So if you were to go over to the JavaScript console and type JSON string and hit enter, you can see that variable was created.
Okay. So is what I'm putting in, because I was struggling with this yesterday too, of putting stuff in VS Code and then trying to see it over here. I had a problem with that last night when I was trying to work on it. I didn't know what I was doing wrong, and I've been trying to figure it out. But
so if you're entering something in VS Code and not seeing it, most likely you're not logging it out. So if you were to go over to VS Code and below the line you've entered, type something like console.log JSON string, and then save, you should see that show up in your JavaScript console.
Let me see.
And then also Christy, another way is if you do node and then whatever your JavaScript file name was, if you did like a script.js, then it will run it in the terminal in VS Code too.
You said node.
Have you guys talked about Node yet at all?
Yeah, that's why I used it. So remember when we were doing like JavaScript stuff in the terminal, we would use node and then whatever the name of the JavaScript file was if we were just doing plain JavaScript stuff.
Oh, right, inside the terminal.
Terminal, right. And
Right,
then it will run right inside the VS Code terminal.
Oh, I forgot all about that. Okay, yeah. I told
Yeah.
you my brain can only hold so much. All right, yeah. So
That's another option, but something you should know is that fetch isn't defined globally within Node. So if you try to make a fetch in Node, that's not going to work by default.
oh, okay.
Oh, good information.
Yeah,
Okay.
there is a way to sort of work around that, but that's maybe out of the scope of my talking right now.
Okay. Okay. I will try to figure
Cool.
out what's going on. I'll stop sharing. Hold on.
And if you have more trouble, don't feel free to reach out.
Okay.
And Ryan, before we go, I think Zach has a question.
Yep.
Well,
Sweet. Zach.
Yeah, so is this what I'm supposed to be getting back for number 3? Am I doing this right?
Take a quick peek at number 3 here. Sorry, I don't have all these memorized. Give her Justin into. Yeah, okay. So for number 3, looks like you need to use Json.Stringify to convert the so that it had like let JavaScript object equals and then sort of an object with some keys and values in it. So you should be able to use Json.Stringify to convert that from a JavaScript object into a JSON object, a string that contains a JSON object.
Okay.
I think I run it.
Still muted.
For that, Zach, there, you should know that if we define a variable in JavaScript console with const and you try to redefine it, it's not going to work. So you got to reload the page, and if you try to paste that again, it will probably work for you. Just a weird little thing with JavaScript console. So you're logging out the JavaScript object, but you still need to convert it to be a string, sort of a JSON object in a string.
So what is the alternative to const
You can use let
or var?
or var. Yeah. Yeah, Stephanie, you're headed in the right direction there. Only the thing is, I think your second line there should be like const data equals something, not const text equals something, but you're headed in the right direction. Zach, is there someone you're looking for that I can help you try to find?
Yeah, was there a slide that had the stringify?
Yeah, there was. Let me see if I can find that. I think you want 138.
Thank you. Okay, I think I see.
Brian, quick question.
Yeah.
I did the John Jacob Jingleheimer Schmidt thing, and I escaped the
Yeah,
double,
nice.
and it still didn't like it.
Still didn't like it, huh?
That's my problem too.
Okay.
Want to make sure that's what's supposed to happen.
Let's take a quick look here. That should work.
Am I?
You want,
So
okay.
where'd I go? Console.
Expect you took J. Yeah, that looks. Oh, do this. Do console.log my JSON string.
It didn't even let me get to that. Oh, console.
I have a guess. I might know what's happening here. If this is what it is, I was really quite the jerk. So notice it doesn't have those backslashes in it anymore.
Right.
So what's happening here is when you take this and you put it into json.parse, it doesn't have the backslashes. Why doesn't it have the backslashes is maybe an important thing. And it turns out that if you want to add a backslash to a string in JavaScript, you have to actually put 2 backslashes in a row. So do something like this. Do like
You have
single.
to escape backslash to escape the quote.
Right,
Exactly.
So
Yeah.
I know what. All right, so I'm trying to wrap my head around it. I know when you're trying to put a backslash in, you have to do the double backslashes to escape. To get the quote in, you have to do double backslash plus the quote.
Yeah. So what you want is you want to feed to the JSON parser the literal character backslash quote. So in order to make that happen, you have to do double backslash quote so that when the JavaScript parser reads that string, it says, oh, you want to put a literal backslash there.
Okay.
It's pretty screwy, but I think that'll work. So if you were to hit enter and then log that out again, yeah, now you got those backslashes. Give that a try. Try parsing that.
All right, thank you.
Yep.
Yes, thank you.
Okay. Stephanie. Oh, you're muted.
There we go. Can I share my screen? Because I'm stuck and I'm looking at your slide and I'm not sure how to make these
Yeah.
match up.
Yeah, go for it.
I'm at exercise 3, by the way.
Okay.
So I was listening to what you were telling Zach, but like, I don't know what this is supposed to look like. I'm matching it up to the slide that says context equals Json.stringify, but
Yeah. So the first parameter to JSON.stringify is a JavaScript object. Right now, the first parameter you're passing into JSON.stringify is a JSON string. So is your goal right now, I think, is to take a JavaScript object and to stringify it into a JSON string. Do I have that right?
so would that be this line?
So that line's defining a JSON string and putting it into the variable called data. So for exercise 3, it looks like there's an object, JavaScript object that I made called let JavaScript object. It's equal to a JavaScript object that has count, start, and end in it. So if you take that code verbatim and paste that into your code editor, that might be a good, oh, you already did that up top. Yeah, nice. Okay, cool. You are missing a closing curly brace though on that. So like on line 56 or between 55 and 56, you need a closing curly brace. Yeah, there we go. Oh. So you see how that matches the one on line 52.
Yeah.
Okay, cool. So you've got your JavaScript object. So now you need to take that JavaScript object and you've got to convert it into a JSON string. So in order to convert from JavaScript object to JSON string, you want to use json.stringify. So json.stringify, it takes one required parameter. And that first parameter is a JavaScript object to convert into a JSON string. So in theory, you should be able to pass that JavaScript object to json.stringify, and it should return back to a JSON string that is all nicely converted.
So I move this in front of this?
You could do that if you wanted to, but I don't think that's not going to necessarily affect directly the JSON.stringifying part. How about this? Take line 61 through 63 and comment that out for now. I think what we have with line 58 and 59 is actually pretty close to what you want. Now, instead of passing data into json.stringify, put JavaScript object there. Okay. So what our code here is doing, like starting on line 52, define a new JavaScript object, and it's equal to an object with keys of count, start, and end. Okay. So that's good. We got a new variable. And then we go down to line 58. And 58, we'll create a new variable called text and store into text the return value of json.stringify. And json.stringify is being called on JavaScript object. So we're calling json.stringify. It's taking that first parameter of JavaScript object. It's running that through the JSON stringifying sort of behind the scenes serialization stuff. And json.stringify returns a text string that contains stringified JSON. And that's being stored in the variable text. And then on line 59, you're locking out that variable text. So I think if you save that and run that, you should have the contents of JavaScript object printed out for you in a JSON string format. Does that make sense?
So then it's line 52 to 59 that's, or?
Yeah, line 52 to 59 is the important part here.
So.
Yeah, there we go.
Okay.
So you see there, it's you've got sort of a curly brace quote, counts, quote. So that's sort of the JavaScript object converted into JSON.
Okay. All right. Thank you.
Yep.
Hey, Ryan, I'm wondering if the confusion is coming from like the difference between how the JavaScript object looks and how it looks stringified, because they look very similar.
They do. Yeah. That's a,
And I and
I'll
I
call it
and I
out.
don't.
Oh, go ahead, Mel. Sorry, cut you off.
No, go ahead, Ryan.
Oh, so keep in mind that the way you can sort of tell the difference between a JavaScript object and a JSON object, because Mel said they look very similar, and you're totally right, they look very similar, is the big dead giveaway is that keys in JSON objects are quoted. So like Stephanie, in your example there, that counts key, it had quotes around it. And in the JavaScript object version, it didn't. Also, the JSON objects that Json.Stringify generates by default are all going to be on one line and all kind of like smushed together. So that might be helpful. In general, though, even though they look really similar, keep in mind that the JSON object that's going to be inside of a string. So the actual like data type of a JSON string in JavaScript is a string. The data type of a JavaScript object is just an object or whatever sort of data type it is in JavaScript. Hopefully that's helpful. Mel, if you want to give that a shot, maybe in your own words too, if you have a better way of saying it, feel free.
No, I think you said it perfect. It'll stick. Probably just take some repetition, but she'll come around. Yep.
For sure, yeah. Also, if it's any consolation, in practice, if you're using JSON with requests, making HTTP requests, you're probably going to use that response.json thing pretty often. And it's probably going to turn out that you don't have to maybe deal with this lower level stuff quite as often, but I think it's important to know it because it still is going to come up pretty often. So, cool. Well, we are sort of at time here.
Yes.
Anybody else? Yeah, you guys are,
This is how we know we need more time with you.
yeah, I mean, you guys are great to chat with. So,
Let everybody go have a great night, Joe.
yeah.
Thank
So
you.
remember,
Good night,
office
everyone.
hours Sunday at 5. That's the plan.
Yeah.
I'll
Yeah,
post it in Slack.
you.
But yep.
Yeah, have
Cool.
a good weekend, all.
You too.
Bye.
Says Sunday at 5.
Office hours Sunday at 5.
Okay.
Cool. Bye.